Hey everyone. So today we're going to do a super fun little project where we will implement our own DAO layer in Java with no dependencies. The only dependency we're going to use is a JDBC driver of the database that we're going to be using. And then we're going to go a step further and implement our own HTTP server. Again, means simple Java. And the only dependency we will grab there is Jackson, just because I don't feel like writing my own JSON parser. So yeah, gonna be fun. Let's start by creating our own project. Let's call this demo DAO, yeah, something like that. Grab whichever Java you feel like it. I'm just gonna grab 21 because why not? Then it's gonna be a Maven project because we will need just those two minimal dependencies. So let's grab a quick start if I find it. And for additional settings, yeah, it's already for me. It's already the correct groups that I like to use. And we can press create. So I don't need any JUnit. We're not going to do any testing. So yeah, I just wrote in here my Postgres and Jackson, and we just press this refresh button for IntelliJ to refresh everything, and we're good to go. Perfect. So first things first, obviously we want to actually create our database. So let's take a look. I already have the Java, Maskarov. Yeah, we won't be needing this. And right under main, we're going to create our own, oh, thank you, IntelliJ, our own resources. In here, we're going to create first of all, our SQL file, just so you know. We have that will define our schema. So obviously, if we're going to do DAO, we need to have a database. So I'm just going to throw the SQL here. Let's make it a bit more visible for you. And we're going to be using Postgres. Yeah, we will configure it a bit later because we haven't created our database yet. And you can see I'm just creating very simple minimalistic table set. So we have a student group, basically, by students belong to a group. So, like a study group or whatever, like a session. Yeah. And it's a one-to-many one-to-many relationship where many students have the same student group. So, but each student has only one student group, but one student group can have many students. And then we have a student class table, and we have a course table, and then we have a many-to-many relationship between the two. And one thing to note is that order of the table creation is important. Obviously, if we're referencing this table in a other table, then the table that is being referenced has to be created first, and then the student, and then the course, and then only student course, which references the previous two. Okay, so next thing we're gonna do is create our own little Docker file. I mean, if you guys have Postgres somehow otherwise installed, then perfect. But I like to use Docker for that, and I use Docker file just so I don't have to, keep retyping a long command with every single environment variable. And you can see I'm just using the fact that I can put environment variables nicely here, and I just put Postgres user, Postgres password, which are admin, and then I have Postgres DB, the database name to be DAO-DB, and I'm literally grabbing the schema skills that we just created, and I'm saying, hey, just throw it in this Docker entry point thingy so that it gets executed at the startup of the database, and that way, we have a nice database to, yeah, we immediately initialize with our tables. And just so I don't forget what just happened. That's not what I meant. Oops. I meant to do readme.md. And just so I don't forget the command, how to write it, I just write a readme and I just write here, hey, this is how we do it. Docker build -t DAO-DB. Dot is important. So you have to execute it in the same folder as the Docker file. And so with a dot, it will look for this Docker file. And then just run it immediately. So that's actually exactly what we're going to do, because we do want to see that it runs. For the love of holy, do not give me PowerShell, which doesn't understand anything on this planet. I just want a simple command prompt. Perfect. So we just grab this nice little thingy and we throw it here. And there we go. We're already building. Like if you want to take a look at it's still running. You can do Docker container ls. You can see that it started 9 seconds ago. This is our thingy. If you want to see the logs with Docker, you can do something like this, and you can see that the logs, it's listening, it's accepting connection, so we know that it started correctly. Now that we know that it started, we can use nice features from IntelliJ and just grab the data source. Which data? Where's Postgres here? Postgres. There we go. And yeah, we use DAO-DB. I mean, you can see, if you remember, in our Docker file, we specified DAO-DB, so that's exactly what we're going to put. We're going to put admin, and we're going to test our connection. And it's all good, fantastic. We press OK. And next thing is we can right away go, we can take a look at our tables. And you see that all of our tables got created correctly. So you see we have course, student, student course, student group. Exactly what we wanted. Perfect. Next thing we go for is we're going to create our properties reader. And for that, we need our properties first. So obviously, just like if you guys use Spring, you know how comfortable it is to have your own properties file. So I'm just going to call it exactly the same, application properties, and I'm just going to throw in here the properties that I want. It's just our data source, username, password, and the port it will be running on. But since we're writing our own vanilla Java, we do need to write our own little reader, and that's exactly what we're gonna do. So let's just give, first of all, let's create a DAO demo, if that's what we called it. Then I'm gonna throw it in util, and I'm gonna call it properties reader. Exactly. So it's an util class, and there's a bunch of logic here, but first things first, we want to define the default class, file for the, we will just by default we'll grab this, so I don't have to retype it. We want to write like a little method that reads all the, like finds this property file, like if we pass in the file name, and loads all the properties from it and returns the properties file so we can use it. Now, in our application, we'll pretty much always use a default one. So we just, we create a convenience method that you don't have to specify a parameter. If nothing is specified, it just itself grabs a default from here. And since we will often be, so we don't have to grab every single property, we can create our own little convenience method that we just right away say, hey, just tell me which key. And again, it will just grab the default property file and look for the properties there. So yeah, now that we created it, let's test it out. I'm gonna just, here I'm gonna grab all the properties. Then let's make a little break here, and then I'm gonna try to print the data source URL, and let's see if it actually can find everything from the class path and everything. And you can see that indeed, this is our properties file. This is what it printed here. And then when we ask to only print data source URL, to grab only that and get it, it also works perfectly. So yeah, I'm happy with this. We can move on to next thing. And of course, next thing is we do want to create while we're in util package, our own little way of getting a JDBC connection, because that's what we're going to be working with. Factory connection factory. Yeah, that's it. So what I do is, using the properties reader, I just grab the properties by the way I define them. So if you remember, I defined them as data source URL, data source username, data source password. So that's exactly what I'm doing. And then after that, life is actually extremely easy. We want to get the connection, and for that, just driver manager, get connection. You don't need any of this old pre-JDBC, I don't remember, 3 or something, load driver, load class, whatever stuff. You can just do this thing since already like 10, 15 years. So cool. Next thing, we obviously now we have to create our domain. So let's do that. We create our own little new package. It's gonna call it domain. Let's create our course, for example. Cool. And I mean, it's pretty much just creating fields that we defined in our Schema SQL. So where's our course? Yeah, you can see it has ID, name, description, ID, name, description, and then just bunch of getters and setters. And then with the same stuff for student, again, we just grab every single field. We create our own getters and setters. And then we create, we want to generate, yeah, I remember I also wanted to generate a string for it. I only need it for student because I'm going to be logging student. So student course file, that's going to be just a domain to, like a domain object to specify the relationship between them, like many-to-many relationship. And we're going to do this one too. Again, very simple. Let's create one also constructor here. And since we're defining a constructor that has all of the fields, I also want one nor constructor and just bunch of getters and setters. Exactly. And last but not least, we have student group. And again, just a couple of fields, getters and setters. Perfect. Domain is ready. Next, we can create our DAO layer, which is also fun thing that we came for. So we're gonna create it like, very nice and cleany. We're gonna create our own generic DAO interface. And let's grab that. Now our generic DAO is gonna be, you will never guess it, generic. It's using generic, which is like, this is the type of the entity that we're using, and this is a key. And it's gonna have a bunch of methods that we need. Oh yeah, I forgot to define an exception. Well, that's important. So let's create our own exception package or something. In here, we create DAO exception thingy. And we just, oh yeah, of course it extends runtime exception. And there we go. Runtime so that, I don't have to worry about the throws DAO exception. There we go. What doesn't he like? Yeah, because, it's interface, of course. So now we're good. So it's an interface. It has all those methods and good. Next thing is we're going to create our DAO layer using a design pattern. And it's my favorite design pattern to use with DAO layer, which is template pattern. It really is awesome. You only have to define your logic once in abstract DAO. And after that, you can so easily keep writing all the other DAOs, and you only need to define a couple of abstract methods that you need. So let's go with that. I remember when I learned it, because it's kind of not very easy to figure out where do you want to put which design pattern, like when do you get the chance to use it. And I remember that, yeah, there was a template pattern. It's just perfect because there's a perfect use case for it, and it's called exactly in a DAO layer, and everyone does it like that. When all experienced professional developers do it like this because, well, that's just the way you should do it. So obviously it's a public abstract class. And we need to import our favorite exception and also our connection factory, and we're good to go. Perfect. I'll just go through this and explain it to you guys. So this is just for us to be able to make a check. So, if you perform an update, it returns you a number. It's just a constant, just another constant for the message. Now, this is a bunch of abstract queries. So in our abstract DAO, I'm just specifying the CRUD operations I'm going to define. And the actual logic is here because, well, all the boilerplate is pretty much the same for every single entity. And the only thing that differs is how to actually sort object into ID statement, because, for course, might have a different ID, and for student table, it might be a different name of the ID. So this is the only different thing. And everything else is exactly the same. So that's why this is where a template pattern comes in. In the template pattern, you do all the meat of the whole boilerplate, everything in an abstract class, in an abstract parent class, and then you just basically create a callback, so to say, for one method that will differ for all the child classes. and then you leave it abstract, and then every single child class which will extend it will naturally have to implement it, and that's just works beautifully. So that's what we're doing here. We're just we have a create method which just uses this, and this is the abstract method. And oh yeah, it also uses, I think, create, yeah, getting, it actually also uses get create query, which is also different for every single class because the table names are different. And then same for read. Again, there is a select by ID query, which will be different for every single one. And then there is a read object. And the read object is basically mapping result set into the specific type that you define in generic. And same for update. Again, you just get an update query and you define your own custom implementation of setting object into statement, which is how you fill out all the fields for the update. And then delete again. You just have a delete statement and you just set an ID into it. Perfect. So now we can create our impl package, and inside of the impl, let's just create our DAOs. So let's create our course DAO. And so we have a course, we have an abstract DAO, we have our favorite DAO exception. Perfect. So as you can see, all we need to implement is we just need to override the abstract methods. So we're overriding all the queries which we define for ourselves, insert into this course, this fields, which is obviously different for every class. And then we just need to specify the callbacks, which is how to set an ID. Well, our ID is this, how to set object into statement, we know that if there is an ID, then it will be if there is an ID, then it's an update statement. If there is no ID, then it's a create statement. And in this case, we don't need to set an ID because it's getting auto-generated according to our, what do you call it, database definition. So continuing here, exactly. And it's just all the callbacks. And we just literally just do the same thing for the student. So student DAO, perfect. Again, bunch of imports to fix, but yeah, it's a generic. It has a type of an entity, type of a key, um, just exceptions, blah, blah, blah. And then all the stuff. Then what else do we have? We have student course DAO, which is many-to-many relationship. And exactly, just so we know how to read those two. Perfect. Exactly. And then we have also a student group DAO. Student group DAO. And just a bunch of imports. Awesome. And we're actually done with our DAO layer. How cool is that? And next thing is creating our own server, which is kind of always cool to create your own server without, any dependencies. So we're gonna, for that, we'll need our own, basically a representation of HTTP request, HTTP response, and stuff like that. First things first, we will need to create a class called HTTP URL, which basically just is our representation of the URL. When we will get a header line from the HTTP request, and it will look something like this: the method, the actual URL, and the HTTP version that's being used. And this class will, just represent it and have all kind of helpful methods to grab the parts of it or whatever. Then, obviously, we will have HTTP status, which is also a big deal. We have to communicate what's our HTTP status, and we're gonna communicate it by, define it by this enum, and just a bunch of stuff. Then, moving on to the fun part, we have our HTTP request. So because we're writing our own server, we'll basically go very low level and implement our own server with sockets. And with sockets, you just basically have to read your all the data from input stream, right? Because that's how just HTTP protocol with sockets functions. And because of that, this class basically like accepts input stream as a controller parameter. And then we read the request. Basically, this is just a complicated loop, kind of complicated, not really. You just grab the input stream, then we have basically the string builder. We read every single line until the line is empty, and then append the lines one by one. And if, because not all requests have content, if it contains a header called like content length, then we will grab that, like calculate exactly the length of it and read exactly so many characters as the content length says. Well, it's just all basics HTTP stuff. And of course, finally, we will close our input stream, stuff like that. And yeah, it's just a bunch of helpful methods. So you will see soon enough where we use it all. And of course, we have to also, after accepting the request, we also want to do the HTTP response. And our implementation of HTTP response is very simple. We have a default status in case we don't want to set anything. We have the ability to set the status by going through with just a number. Then yeah, this is how we build our own response. The code, the message, the line separator content, and we just write it to the output stream that I called network. And that's it. We're ready with HTTP. Now moving on to the fun part of creating our own controllers. Controller. Awesome. Now we can start by, first of all, we create an interface called a controller. Controller. And this interface is going to have a bunch of stuff. So because, yeah, exactly, we're creating our own interface. Not net. So then we're going to have our own, we're just using our defined HTTP response and HTTP request. And then we're referring to our statuses. Exactly. And afterwards, so just to walk through it, it has a method called handle request, which is just a default method. I'm fully I'm using heavily here as a default message just so I have less stuff to write in the implementing classes. And it just, if it gets a post, then it directs to the handle post. If it sees that the method of the request is get, then it directs to get, put to put, delete to delete. That's all I defined because I don't think we will need anything else. And it just defines a bunch of default methods for responses. So, I don't have to every time create it, set it. I just have a bunch of helpful, methods. So I just directly call them. So now that we've covered our interface, we can create our first controller. Let's call this one course controller. Perfect. And because it implements the interface controller, it already has a bunch of boilerplates. The only thing is it has to implement these four methods. And exactly, I'm just going to show you right away how it's going to look. So for the post, it's very simple. We get our content, and in HTTP request, and then I remember I wrote this method. So get JSON context. It just checks with the regex where in the whole thing do we have the JSON, and if we find it, we will return it as a string. Then next thing is we define the object mapper in the controller interface, which is just from the Jackson library, the JSON parser, and I'm just saying, hey, read this value as a course class. Then I just call our DAO and I say, hey, please create it, and it just does it with an abstract DAO. And last but not least, I do return the value back because once we create it, there will be an ID set inside of it. Because we specified that we want generated keys to be returned, and we grab them from the result set and put them in. to the entity, and that's why I'm just returning the entity so that user who called it can see the ID and maybe use that ID in the future to query it. Then the handle get is very simple. I check that only if there's a amount of queries is correct because I expect course/ID. I will process it. Otherwise, it's not found because otherwise the URL obviously is not this URL. And then exactly we grab from the segment. So because you have to imagine it being something like this, course one, right? And so segment one, just index of one, it just grabs this ID. Then I read it with this ID, and then I build the response. And then the object mapper maps the entity into the JSON, so into the string JSON, and then I send it back. So nice and easy. And for put, it's basically follows the same logic. I check that the URL is correct. I check that I can get JSON content out of it. Then I grab the ID. I build the object with an ID, and then I just update the object. So basically with input, I just, I allow the user to overwrite all fields except an ID, obviously, for a given ID. And delete is also very fairly simple. Again, I check that it still follows the same schema. It's basically course slash what do you call it? Course slash an ID, something like this. Then it will, otherwise it's not found, if for whatever reason he wrote some other stuffs here that I didn't define. And exactly, and I check that if that's the case, I grab the ID with a segment of index one, and I just call delete on it. And that's easy breezy. So next controllers that we want to create is a student controller. It also implements a controller, and it pretty much has all the similar logic. Exactly. So we want our own HTTP response that we defined, and student course doesn't understand what student course is. Fun. Student course. There we go. Oh yeah. So yeah, again, we have student DAO. Here I put some other DAOs too. Also, by the way, obviously, naturally, in a real project, please don't just grab the repos in the controller layer. You should be having a nice in-between service layer. So controllers go to servers, services go to repositories. But in this case, it's just a demo project, so I'm a bit more interested in saving time, and I'm a bit afraid also that creating way too many classes and explaining way too many things also interferes with you guys being able to follow everything and understand everything. And here, just because we did the whole many-to-many relation, but I also wanted to show that. So I allowed two versions of get. One is a simple, let's just do this. One is a simple student and some kind of ID. So I extract the ID and I get the student and I return it. That's nice and easy. The other one is in case I allow for exactly as I already wrote it for a get with a student ID and then courses. So if you want to get all the courses for a given student, and this is where the many-to-many DAO comes in. So I grab student course DAO, I find all the elements by student ID. So because we will have a lot of entries in the database, we can actually see it here maybe where we have exactly. So we have student ID and course ID, and they're basically mapped many-to-many to each other. And I grab all the ones that match for the student ID, and then I stream through them. Then I get the course ID for all of those, and with the course DAO, I grab all of them and I collect that to list and I just return it. And this is just a basic helper method to get the student. Yeah, I should basically read the student by ID. This is just put, so override the data of a student by an ID, and this is delete. Cool. Now, following controllers, we basically want to create, some kind of a front class that deals with the whole delegation, which controller gets to do what. So, for that, I create a front dispatcher class. And yeah, it's relatively simple. I just throw a bunch of stuff here. Yes, okay, exactly. So it gets a connection socket because, like I said, we'll be building our own server with sockets. Then we handle the request. That's the method we're going to call on it. And it just basically grabs the input stream, reads it, then gets a response, delegates to handle request, and handle request. This is it just it chooses the correct controller based on the endpoint. And so if the endpoint starts with students, then we will be looking at a student controller. If it starts with a course, then we will be looking at a course controller, and then we will just let the controller handle the request. So this is just a delegation class. Basically, it delegates to the correct controller what needs to be done. And I use a system out print to basically do a little bit of logging. Obviously, you should be using a real logger, but again, I wanted to, it's already quite a big project. It has already quite a lot of material to cover, and I wanted to minimize the amount of new things I bring in, new dependencies. Yeah, I wanted to really keep to those two things, which is DAO layer and um, the whole creating our own server in Java. Honestly, that's quite enough to go through and understand in first go. And of course, at the end, we want always connection close. Uh, we should probably throw it in that and finally, honestly, just to be nice and clean. Oh, it's so nice, and it's that one also has. That's why I wrote it here, as you know. Okay, cool. Let's just do it here, maybe. Let's be modern. Connection socket close. Close? No, doesn't work. I kind of imagined that that would work. Why can't I do it? Like dot close. Because basically I want to provide an implementation of auto closable here. Oh yeah, I don't even have to. It will understand it. Yeah, right. I forget. So then I don't have to do all of this. Yeah, perfect. So yeah, only one thing is left. Our own HTTP server. For that, we just create basically a runner class. We'll call it HTTP server. Bam, bam, bam. And this guy just has our favorite get property method. If you remember, we developed it, to grab anything we want from our application.properties, where we defined it to be 8080, big surprise. And then, I just use a single thread executor, and I'm saying, well, true, accept our socket should accept a connection. And this is a blocking call. That's why we don't just create 1 million. We don't just through it. It just hangs here and waits until there's a connection. Once there's a connection, I submit it to a front dispatcher in a separate thread, and I'm uh, theoretically available for the next. Except I use new single thread, so essentially it's just a single-threaded application. But we could, make here, a thread pool, new cache thread pool, and then you can get here quite a whatever amount of threads you would like, and you would have a proper server. Just for our purposes, new single thread executor is just fine. So yeah, we are ready to test it. I think I forgot to mention one thing. In front dispatcher, yes, that's what I want to say. So we're going to do the testing we're going to do with Postman. Postman has this funny thing. Doesn't happen in browsers, doesn't happen in SQL, but with Postman, if you work with sockets, it sends you first empty request, trying to just see if the connection is if the socket's just there, and then because it has nothing inside, whatever you try to get out of it ends up throwing a null pointer exception. But it's just the first request of Postman. The second one is exactly what you actually told them to send. So don't ask me why Postman works like that. I don't know. But basically, we swallow an exception here and just return a normal response, and then Postman is like satisfied. Oh, okay, the socket functions properly, and then it sends a correct thing we actually wanted to send. So you're not surprised by this code here. So yeah, let's go to our server. Let's start our server. Bam, bam, bam. And guess what? Our server is ready to accept connections. So Let's give him some connections. So we actually don't have anything in our database right now. So we will start by creating some entities. So we just basically send to our localhost 8080, pass student, post request, and we give it first name, last name thing is in our properties of our class, of our student. For example, Diana Smith. We send it, and you can see here it was handling a post method. It matched it to the student controller. It was handling it, and we even got the response back. Student was an ID of 1. We didn't assign it any groups. First name, last name. It's all set. And if you want to go and check it out, indeed we have it. That's our student. Uh, let's create another one. Let's make also John Smith. Let's send that guy. Again, we have it. Again, if we check it, it's here. Now, uh, let's say, and I'm just going to create some data just, to save some time. Let's say we also have some courses, you know, uh, we can just do it here. Let's give it one. Let's call this course biology and biology course description, right? I'll just show it here. Perfect. And then, oh yeah, and then I want to create a relationship, student course, and I want to say that student one is signed up to this course. Exactly. And I also send it to database. Perfect. So now if I go, yeah, we can, by the way, get student. Let's grab student number one. And you can see this is our Diana Smith. And we can go to student ID and say that we want to get a student. I'll just clear the previous response. If we want to get all the courses for student one, we correctly get biology description. So everything works as we want. If we feel like we could, let's just grab our student number two. That was John Smith. Let's make him Mr. John, and let's make him Vic. And yeah, that's our student number two. So this gets 204 no content, which is just, for us, just a confirmation message for us that everything worked. And now if we try to get our student number two, it is indeed now Mr. John Wick. Haha. So yeah, that's pretty much all there is to it. Hope you learned something and see you next time.